Alright, so welcome back, and today what we're going to do is we're going to talk about functions versus non-functions. So on a function, what we need to remember is that basically what we're looking for is the x value, whether or not it repeats or if it doesn't repeat. And so what I'm going to do is I'm going to go through some representations. The first one is going to be a table. So we have our x and y column, and then we have some random numbers like I'm just going to go 0, 1, 2, 3, and 7. And then here we can have 1, 2, 1, 4, and 8. Alright, so this is a function because if I look here at the x column, I have no repeating x values. In other words, I only see the number once. So for instance, on a non-function, I'm going to see a table, but instead of having my x's not repeat, I can have something like this. And let's use the same numbers again. 1, 2, 1, 4, and 8. So the reason I'm showing you guys the same y column is to emphasize the fact that the x column is really where I'm focusing my energy on. And if you notice right here, I have 2 repeating x values. So for a function, no x values are going to repeat themselves, and for a non-function you will have 2 x values that do repeat. Now the third example of this, which you would still see in here, but I'm going to write in blue, that is a function, is say if I have a repeating x value, like say 0, 1, 2, 1, and 7 again, but had the numbers been the same, so instead of 1, 2, 1, and then here instead of I had the 1 and the 4, so if I have 1 and 2 again, these two numbers right here, even though I have a repeating x value, they have the same y value. So really it's like repeating yourself. It's like repeating yourself. It's like repeating yourself. So you don't really have to put that set of numbers in there, which is what makes it still a function. So we have that, and so the other representation, this is called a table. Alright, so this is our table format. And then the other one that we have is called our ordered pairs. And so, here, let me write that up here. Ordered pairs. And that's basically using the x comma y method. So what I'm looking at, I'm going to use the same numbers. So 0 comma 1, big comma, 1 comma 2, big comma, 2 comma 1, 3 comma 4, and 7 comma 8, right? This is all the first numbers are my x's, all the second ones are my y's. And so for our non-function example, the way it would look is like this. 0, 1, 1, 2, 2, 1, 1, 4, and 7, 8. And if you'll notice, this right here, I have an x value that repeats itself with 2 separate y values. Whereas here, if I look at all of these, none of the x values are the same. So there's our second representation. Alright, our third representation is going to be called a mapping. Alright, on a mapping, what we do is we draw 2 big circles. Okay, one for the x's, one for the y's. Let me move this back up. There we go. Alright, and then we put in all our x values in here. So 0, 1, 2, 3, and 7. Here, we'll just try to include that there. All right, and then we put our numbers again, 1, 2, and 8. Oh, and 4. Forgot about 4. Yeah, we'll include that one in there too. All right. There, make it all look like it's part of the oval. All right, so what we want to do with this is we just want to map out what the 0 goes to. The 0 goes to the 1 goes to the 2 also goes to the 1, the 3 goes to the 4, and the 7 goes to the 8. And so if you notice, all of these only have one arrow going to the other box. So this is our X box, and this is our Y box. Not really an X box. But our non-function version of this would look like this. 0, 1, 2, and 7. So this is our X column. And our Y column is going to be 1, 2, 4, and 8. Notice I don't repeat the number that happens twice. I just draw my arrow to it. So 0 goes to 1, 1 goes to 2, 2 also goes to 1, but then 1 also goes to 4, and 7 goes to 8. So this number right here, this one is causing this to not be a function. Notice that there's 2 arrows coming out of the same number, and that's what causes this to be a non-function. So on a mapping, you're going to see 2 arrows coming out of the X column on one number. Ordered pairs, you're going to see the X value have a repeating number, and in the table form, you'll have 2 of the same X numbers going to different Y numbers. Alright, and so our final look at function versus non-function here on the graph is going to be pretty much the same thing. Again, remember, this is our X column over here, right? And up top here is our Y column. So what I want to do is I want to just, here, we'll draw some points here. 1, 2, 3, 4, 5, 6, and 7. Alright, so what you notice with all of these is that if I were to put these in ordered pairs, this would be -6, 1, this would be -5, 2, -4, 2, and -3, 1, and so forth. Now what you'll notice is none of these have X values that repeat themselves. I only have the one X value. So like here I have +3, here I have -1, here I have 2, here I have -3, -4, -5, and so forth. Now I do have repeating Y values, which is not the same thing. If you notice here, I have the repeating Y values, just like on the last one. And so what I'm looking for, and it's called the vertical line test. If I were to take a vertical line from, say, like that, okay, and I move it anywhere on the graph, this line will only touch the graph one time. So anywhere I move this, I only have one dot touching it, so that makes this a function. Now, if I were to add one extra point to this, like say here, where I have -4 going to both 2 and +4, then when I move my vertical line, I show 2 dots touching my line, which creates a non-function. So just like on, there we go. Alright, so just like on the dots, if I were to draw, say, a parabola, let's see, 2 and 4, 3 and 9, let's see, 7, 8, 9. No, it didn't. It was just hungry. It just took a nibble. Alright, so here is what a quadratic looks like, more or less. And if you notice that if I take my vertical line again, anywhere on this graph, this line only touches the graph one time. Okay? Now if I take this and rotate it in any direction really on its side, oop, don't do that. It's not moving. Alright, there we go. If I rotate it on its side and I take my red line again, how many times is my red line touching? Twice. And so because I have the 2 points touching my vertical line, this creates a non-function. Alright, I hope this was a good enough example for y'all. If not, feel free to ask me for some questions or for some answers, and if not, you can also look up some more stuff on YouTube. Alright, so our last thing that we need to discuss today are function notation. In other words, when I plug in a value, I get something out. So in this case, it says, for each function, evaluate f of 0, f of 1/2, and f of -2. And so really all this is me just plugging in values. So if I have f of 0, that means the x value that I'm plugging in is going to be 0. So 4 parentheses 0, which 4 times 0 is 0, and 8 plus 0 is 8, right? And so we'll talk about that here in a second. So f of 1/2 is no different. I just take the same formula that I just had, times 1/2, and I see what my result is. Half of 4 is 2, so 8 plus 2 gives me 10. And lastly, f of -2 is equal to 8 plus 4 times -2, which is equal to 8 plus -8, which is a value of 0. So if I were to rewrite it out and make it even simpler, I could say that f of 0 is equal to 8, f of 1/2 is equal to 10, and f of -2 is equal to 0. Everything in this column is my x value, and everything in this column is my y value. So all this is just plug and chug, guys. So nothing too terribly difficult. Just do what it asks you to do and follow the rules.